So the new topic, law of conservation of linear momentum in system of particles. The statement is this: when the total external force acting on a system of particles is zero, the total linear momentum of the system is constant. When the total external force acting on the system of the particle is zero, the total linear momentum of the system is constant. What does it mean? If I draw some diagram, you can understand. Otherwise, you cannot understand it. We have a system of particle m1. We have a system particle m1 moving with the speed u1. Another mass m2 moving with some speed u2. Another mass m3 moving with the velocity u3, etc. All m1, m2, m3, all the masses are inside a system. Okay, listen, all of you please listen. Listen. Ashin, everyone listen. So what I am saying is, we have a system or container. Think like that. We have a container containing two or more masses m1, m2, m3, etc. All are moving with some velocity. m1 moving with the velocity u1, m2 moving with the velocity u2, m3 moving with the velocity u3. This is the initial state. After some time, I am not applying any force on the system. In this closed system, I am not applying any external force. That is written here. No external force applying on the system. After some time, the velocity of each masses has been changed. Initially, m1 has velocity u1. After a few seconds, the velocity of m1 is changed to v1. Velocity of m2 changed to v2. m3 changed to v3. So initial velocities of the bodies are u1, u2, u3. After some time, the velocity has been changed to v1, v2, v3, etc. But I have not applied any external force on the system. So law of conservation of linear momentum of system of particles says that if no external force, total linear momentum is fixed, constant. Meaning that only theory question will be asked, don't worry. Total linear momentum is constant. Meaning that, all of you please listen. I will clarify your doubt, but let me complete it. Let me complete first. Says that initial, what is the total linear momentum initially? Momentum is mass into velocity. You have already studied. Momentum is mass into velocity. m1 has the momentum m1 into u1. Velocity is a vector quantity, so let me put an arrow above u1. m2 has the velocity u2. So the momentum of the mass m2 will be m2 u2. Momentum of m3 will be m3 u3, etc. This will be asked as a theory question, don't worry. But for competitive exams, there will be numericals. I will discuss numericals, outside NCERT problem, I will consider later. For the time being, we are focusing on textbook problems. So this is the initial total linear momentum. m1 u1 plus m2 u2 plus m3 u3, etc. It will be equal to the final momentum. m1 v1 plus m2 v2 plus m3 v3 plus, etc. This is true only if no external force. Understood? If no external force, the total linear momentum. Mass into velocity is said to be linear momentum. There is another type of momentum. We will learn it later. Angular momentum. There is another type of momentum we will learn. When I teach you rotation, I will explain angular momentum. Here I am talking about linear momentum. So total momentum is conserved. Total initial momentum is equal to total final momentum. So this is law of conservation. Okay. So all of you please write down. If you don't understand anything, please ask. If you don't understand anything, you can ask me. Say the Ashlin, Devasri, Raj, Aaron. Okay. If you have written, you may raise your hand. One question paper, one answer paper is there. I will send the mark. Okay. I remember one exam was conducted. Remember that. Sorry for the delay. I will correct it by today. Sorry, by tomorrow I will send it. And we need an exam. I will announce the date. Finished? No response. If you have finished, raise your hand. Raj, you finished. Say the, sorry, Devasri completed. Aaron completed. Ashlyn's name. Everyone finished. No problem. Numericals. Memorize it. This one I will discuss later. Rotation. Now we are going to learn about rotation. So far I was talking about. So far I have been talking about. Please mute your audio, Aaron. Everyone, please mute your audio. Now we are going to learn about rotation. When we learn about rotation, there is an important term, moment of inertia. What do you mean by rotation? All of you please look here. All of you look at this diagram. I will discuss, don't worry about this term. I will discuss this moment of inertia. Definitely. Before that, we are going to learn about rotation. Not a translation motion. I am talking about rotation. The object can be spherical, cylindrical, or it can have any shape. The body can have any shape. It is rotating about an axis. For example, this dot line is an axis. This is rotating about an axis like this. Either clockwise or anti-clockwise. Understood? Rotating like this. The speed of the rotation depending on two factors. I mean, if I apply some force on the body, understood? At this point I am applying some force, so then it will rotate about this axis. The speed of the rotation depending on two factors. One is the mass of the body. The more mass, the less speed of rotation. You agree with me? The more mass of the body means less speed of rotation. If I apply a fixed force on the body, okay. And any other factor? Any other factor? Can you tell me any other factor? The more mass, less speed of rotation. That is okay. Any other factor? Any other factor depending on speed of rotation? Okay, then I will tell you. Suppose, for example, suppose this body has the mass, say 5 kilogram. Suppose this body has mass 5 kilogram. Understood? I have another body, something like this, extremely narrow. Okay, maybe having some sufficient height. I have a cylindrical body made up of another material. I have another material, but the mass is still 5 kg. The mass is still 5 kg. I want to rotate about this axis. I am applying same force. Do you believe that the speed of the rotation is identical? By saying that the masses are equal, hence the speed of the rotation same? No. The speed of the rotation depending on mass and also the distribution of masses. I mean, to understood the distance of each point masses from the axis of rotation. how the point masses are distributed away from the axis. Here in the first case, the distribution is too large, understood? The distance of each point masses have a longer length, understood? Each point have a certain mass. The distance from the axis is much larger in the first case. We denote it by the letter R. But in this case, each point masses are nearer to the axis of rotation. So in this case, what happens is, second one will have a much higher speed compared to first body. The second body will rotate much faster compared to the first body. So the mass alone does not determine the speed of rotation. My point is this: the mass alone does not affect the speed of rotation. Each point masses are located at what distance? Each point masses are located at what distance away from the axis of rotation also has a role. The more distance the masses are, the more distance, the speed will be much slower. Here the points are very nearest to the axis, so the second body will be much faster in rotation compared to the second body. So 2 point factors are there, M and R. 2 factors are there, M and R. Mass and distribution of point masses from the axis. The 2 factors are there, determine the speed of rotation. You got my point? Devasri, Raj, Aaron, you got my point?
Yes, sir.
Okay. Say the Ashlyn, you got my point?
Yes, sir.
Okay. So M and R both are very important. I am going to define moment of inertia. Right now, you cannot understand the application of moment of inertia. The application of we are going to learn an important topic, moment of inertia. The moment of inertia is a term which is widely used for the rotation. In order to find the speed of rotation, we must know the moment of inertia. For example, I am applying a force at this point, say 100 Newton. The shape is familiar to us. At what speed the body rotates? At what speed the body rotates? Or at what acceleration the body rotates? Or what kinetic energy the body has? If it is rotating, it has kinetic energy, definitely. Every point is rotating, everyone will have kinetic energy. So if you apply some force, it will rotate. There are so many factors associated with the rotation. At what speed it is rotating, at what acceleration it is rotating, what is the kinetic energy of the body, rotating body. So many terms we have to find out. In order to find out each of these terms, we must learn moment of inertia. Once we learn moment of inertia, we can answer all these questions. We can answer all the questions once we study moment of inertia. So let me define moment of inertia. The application of moment of inertia we will learn later. For the time being, let me define moment of inertia. Okay. Right now, don't ask me why we are defining in this way. Don't ask me like that. Definitely, I will explain the application of moment of inertia later. So all of you please listen. Moment of inertia is used to determine the speed of rotation. Okay. So I am going to define moment of inertia. All of you please listen. So we have a axis. Axis is necessary. The entire body is rotating about the axis. This is the axis. I am going to define moment of inertia. Okay, all of you please listen. This is not a point object. This is a much larger object. This is actually system of particle. I can say that this is the system of particle because every point has certain mass. If you consider a point, it carries certain mass. Understood? Okay, so the distribution of each point masses from the axis is very important. It has a role in determining the speed. Suppose we have each point has masses like m1. This point object has mass m1. This one has mass m2. This one has. There are so many objects. Okay, This point has m3, mass m3, m4, m5, etc. Okay. So the distance from the axis is very important. So suppose m1 is located at a distance of r1 meter away from axis. The sign of r1 is not considered. To what distance away from the axis, that is r1. Suppose m2 is at a distance of r2 meter away from the axis. m3 is located at a distance of r3 distance away from the axis. m4 at a distance r4, etc., etc. So in this way I will consider all the point masses on this body. Now I am going to define moment of inertia. Right now you need not ask why we are defining in this way. Definitely there will be application. I will discuss. So moment of inertia denoted by the letter I. Moment of inertia denoted by I. So moment of inertia is equal to each point mass is to be multiplied with the square of the distance. Each point mass is to be multiplied with the square of the distance from the axis, and we have to take the sum of them. Addition. m2 r2 square. I will give you example, don't worry. m3 r3 square, m4 r4 square, etc., etc. All the masses to be multiplied. Don't leave any mass. Every mass is to be considered. Each mass is to be multiplied with the square of the distances. And we will add everything together. We will get a number. That number is said to be moment of inertia. Once we find moment of inertia, I will be able to find the speed of rotation, kinetic energy, acceleration of rotation, everything I can find out. We will learn that formula later. So this is moment of inertia. Definition is only this much. So the unit of moment of inertia. Unit is, you know that mass has the unit kilogram. Mass has the unit kilogram. R1 is actually distance, right? Distance has the unit meter. So R square will be meter square. So unit of moment of inertia will be kilogram meter square. So this is the definition. Okay. You may write it in sentence. Suppose m1, m2, m3 are the point masses, r1, r2, r3 are the distances from the axis. Then moment of inertia equal to this. Okay, that is the definition. Unit is kilogram meter square. Okay, all of you please write down. I will discuss one question. Okay, please write down. If you don't understand anything, you can ask me. Devasri okay, Raj okay, understood. Ashlyn okay, clear. Everyone is clear, okay, finished. Let me discuss one question. I will discuss a few problem outside NCERT, then only you can understand, okay. We are going to learn about rotation. Before learning rotation, moment of inertia is very, very important. Look at this question. Find the moment of inertia of the following rotating body. Can you see a rod is there? Understood? A rod is there. You can see. Rotating body, it is to be rotated about the middle. I have drawn an axis passing through the middle point. The entire thing is to be rotated, the direction I have shown. This entire thing to be rotated about this axis. Understood? Total length is 4 meter. Okay. At this one end, 3 kilogram mass is fixed, attached, firmly placed. Okay. And another mass 4 kg is placed at the other end. They are firmly fixed. When it is rotated, it will not leave. Okay. Firmly fixed. So question is, what is the moment of inertia? This entire system is system of particle containing. This system of particle contains only 2 point masses. One is 3 kg, other one is 4 kg. These are the weightless rod. This point does not carry any mass. We assume like that. This road is weightless. Understood. The weight is not considered. If the question does not talking about the mass of the road, we will assume that it is weightless road. The question did not say anything about the mass of the road, so we assume that it is weightless, massless road. Very small mass. Okay. So only two masses in this system. So M1 is 3 kg. M1 is 3 kg, which is located at what distance from the axis? M1 is 3 kg, which is located 2 meter away from axis. The distance, we will not consider the sign. And any other mass in this rotating body, 4 kg is there. Another point mass is there, 4 kg, which is located at what distance away from the axis? 2 meter itself. Any other point masses in this rotating body? No. The road is massless, so okay, we are not considering that. So the moment of inertia about this axis I am going to find out. All of you please remove your raise hand, listen. Moment of inertia is given by formula m1 r1 square plus m2 r2 square. If more masses, m3 r3 square, etc., etc. But only 2 point masses are there in the system. Simply substitute the value 3 into 2 square. Simply substitute the value m2 4 into 2 square. You will get 12 plus 16. I don't want to show the calculation. 28 kilogram meter square. The unit should be mentioned. Okay, very important. The moment of inertia has the unit kilogram meter square. So all of you please write down. And if you don't understand any step, you please ask me. I will repeat. Okay. Aaron finished. Ashlyn completed. Raj completed. You don't miss any physics class. This chapter is very difficult chapter compared to other chapter. The most difficult chapter is this. Okay, so don't miss any class. And also you can ask me doubt. Whichever doubt you have, you can ask me. Raj, Aaron, say the understood. Okay. Devasri, have you finished? Devasri? You are not responding. Devasri, you finished. Okay, completed.
Completed.
Okay, yes. Very simple question. I just want to check whether you have understood the previous question. You please send me the answer through WhatsApp right now within 2 minutes.